All right, so we are going to continue on our note sheet from the other day. So I'll go to my 490 folder and our Unit 0 notes. And just to recap, after our interval notation that we did evaluating expressions. We just did some rules of exponents, which we just had a Kahoot on. We also have been simplifying radicals, so I think we are hopefully starting to get the hang of those. Last night's or the last class's homework assignment was the polynomials and some operations with the polynomials. And so this is a little bit different. So we are throwing a bit of a hodgepodge at you guys, but we are going to be factoring. And so when we're factoring, we do have a polynomial here. And so that would be, just to kind of tie in from yesterday, a 7th degree trinomial. But what we want to do is try and change it from an addition problem to a multiplication problem. Okay, because right now we are adding three things together. That's what makes it a trinomial. We want to see if we can make it into factors. So the first step in factoring is always to look for a greatest common factor. So I'm looking at our numbers here at -16, 8, and 4, and I know I could factor out a -4. You could also factor out a +4, but I always like to take the negative out first. So I have a -4 factored out, and now for my variables, I have 8 to the 7th, 8 to the 3rd, and a. So I need to take the lowest exponent, which is a to the 1st. So when I then take -4a out of that guy, I am left with 4a to the 6th. Okay, because remember, if I were to distribute that, -4 times -4 would be -16. And a times a to the 6th would be a to the 7th, because we are adding the exponents. So the tie-in between those rules of exponents. For the middle term, if I take -4a out of 8a to the 3rd, I get negative, so I'm going to write minus, whoops, not 4, minus 2a squared. Because again, multiplying those two would give us positive 8a to the 3rd. And now this, don't miss this little thing here, right? If I take -4a out of here, I need that placeholder on the end. I need a -1 on the end, because -4a times -1 would be positive 4a. All right, so we have changed it from, instead of adding three things together, we're multiplying two things together, multiplying this times this. So that's what factoring does, is it changes it into a multiplication problem, which we then can cancel or use zero product property or do a whole bunch of other things. So our first thing we always want to look for is a greatest common factor. But as I look at B, there is no greatest common factor. There is nothing that goes into x squared, -3x, and 18. But I noticed that this is a trinomial. So we did some foiling yesterday, and we are now, in a sense, reversing that process. So I know in a trinomial, I'm going to try and factor this into two sets of parentheses, two things I'm going to multiply together. Well, my first two terms need to be x and x, because x times x is x squared. Now my last two terms, I know have to multiply together to give me -18. So I have some possibilities here. I know that factors of 18 might be 1 and 18, might be 2 and 9, might be 3 and 6. So those are all possibilities. But I know that my middle term, when I add or subtract them, I have to get a -3. Therefore, this is going to be the combination that I'm going to choose, the 3 and the 6. Now I want it to be a -3x in the middle. So that means my 6 has to be negative. So I have -6x and +3x. So this is how it is factored. Now, until you get really good at factoring these trinomials, it's always a good idea just to refoil this out. X times x is x squared. minus 6x plus 3x minus 18, which does reduce to x squared minus 3x minus 18. So we factored it correctly. And again, the boxed part, this is our answer, what is in the box. Okay, next problem. Always want to look for a greatest common factor first, because I look at both C and D and I say, oh, the leading coefficient is not 1. And those are harder to factor, those trinomials. So I always want to try and factor it out if I can. In fact, in C, I believe I can factor that 3 out in front. I have 3 times x squared minus 8x plus 12. So I factored that 3 out. I'm not done yet because I still have to see if that inside stuff factors, but it does look much easier. It does look much easier than it did before. So I'm going to try and factor, I have my 3 out front. I'm going to try and factor that trinomial. I know my first 2 terms are x and x. I should have written that down first. My last 2 terms have to be factors of 12. Well, it could be 2 and 6, could be 3 and 4, could be 12 and 1, but I know that I have to get 8 in the middle. So 2 and 6 would give me 8, and it would give me negative 8 if they are both negative. So my answer is 3 times x minus 2 times x minus 6. And of course, the order there doesn't matter. You could write 3 times x minus 6 times x minus 2. That would be perfectly fine. Because when you're multiplying across, you get the same values. All right, part D is, again, a trinomial. The leading coefficient is not 1. So I want to try and, sorry, I'm responding to a chat here. I want to try and factor out the 2, but it doesn't factor out. So I'm still going to use my 2 sets of parentheses, but I'm going to have to use a little bit more trial and error here, perhaps. I know that my first 2 terms have to give me 2x squared. So I will make 2x and x those first 2 terms, because 2x times x is 2x squared. Now my last 2 terms have to give me 5. And 5 is a nice number because it's prime. So it's either 1 and 5, or maybe it's 5 and 1. And I'm not sure which one, so I'm just going to guess. So if I were to guess 1 and 5, I'm going to kind of test and see if that would be correct. If I were to FOIL this, I would have 10x on the outside and 1x on the inside, but I can't get negative 3x from 10x and 1x. So I know that I don't have them in the correct order. So it's not 1 and 5. So let me try and switch those, 5 and 1. Well, now I have 2x on the outside and 5x on the inside. And I can get negative 3 if I have negative 5x and positive 2x. So that is my factored form for D. Any questions yet? I did get a question in the chat of whether we can use different methods. There's slide method or split the middle. If you have a method that works for you, go with it. Anything that you do to get the correct answer when it comes to factoring, you can use any method that you want. Just keeping in mind that a lot of times time is of the essence. So whatever method you choose, you want to get good and quick at it. All right, part E, these are perfect squares. So no GCF, it's not a trinomial, but perfect squares are actually one of those shortcuts to factor where your first 2 terms are the square root of the first number, and your last 2 terms are the square root of the last number, and one's a plus and one's a minus. So that factors into x plus 8 times x minus 8. All right, F is similar to C. I can see, I think I have a greatest common factor here, and then I'm going to be left with a trinomial. So let's look for our greatest common factor. I know 8 can go into all those numbers, and my lowest exponent for x's is x squared, so I'm going to factor out an 8x squared. That leaves me with x squared minus 3x minus 10. But I need to make sure I check whether or not that part factors. So let me do that. I'm going to use, and I really like to use the trial and error method. And, you know, again, I had the question of, can you use other methods? Yes, if you have one that works for you, go ahead and use it. I just think trial and error, the more that you kind of play with numbers in your head, kind of the better you get equipped at handling those different situations. Factors of 10 could be 5 and 2. If I had -5 and +2, then I would get -3x in the middle. All right, so I'm going to keep moving right along. On G, it is a trinomial. I cannot factor any GCFs, so I need to have my first two terms would be 5x and x because they give me 5x squared. My last two terms have to be multiples of 6, so it might be 1 and 6 or 6 and 1. Well, I can see 1 and 6 is not going to work because that's going to give me 30x and 1x. That's no good. And if I were to try 6 and 1, I'm getting closer because that's 5x and 6x, but I still can't get 13 in the middle. So I know that hopefully 2 and 3 works, or sometimes they are not factorable. But if we were to try, let's say 2 and 3, I have 15x and 2x. Now, if I had positive 15x and negative 2x, or negative 15x and positive 2x, those both would give me 13. In fact, here I would get negative 13, so I'm in good shape in the middle. But the problem is the last two terms have to be of the same symbol to give me positive 6. So this is a bit of a tricky one, that 2 and 3 do not work in that combination. But if we were to make 3 and 2 and both be negative, now I do have positive 6 on the end, and I have negative 10 and negative 3, which is negative 13x. So therefore, this is the correct completely factored form. All right, for H, I'll look for a greatest common factor. And so I know they're both even, so 2 goes into both of them. So if I were to factor a 2 out, I'm left with 25 minus 4x squared. Now these are perfect squares because the square root of 25 is 5 and the square root of 4x squared is 2x. So that binomial factors into, remember, square root of the first one goes here, square root of the second one goes here, one's a plus, one's a minus, and that is our fully factored form. All right, any questions on that row?
I have a question.
Yes.
On the last one, if you put 2 plus 5 instead of 5 plus 2 for the first term, would it still work?
Yes, 2x plus 5. Yep, that'd be fine. All right, good question. Of course, because if you're adding, order doesn't matter there. All right, let's move down to I. So it's a trinomial. So we have x and x. And let's see, factors of 24. Well, it might be 2 and 12, because that would give us 24 and 10, but it might also be 6 and 4, because that also can give us 10. So we have to be careful. Remember that their signs have to be different so that when we multiply them, we get negative 24. So that being said, if I had positive 12 and negative 2, those are different signs, but give us a positive 10x in the middle. So that would be factored. All right, for f, I'm going to factor out a common factor. I can see that 5 goes into all the numbers. For our variables, I'm going to use the smallest exponent for the x's would be x squared. For the y's would be y to the first. And I cannot factor out a z, even though there's one here and here, there is no z in that term. So that is not a common factor. I can't factor that out. So if I factor 5x squared y from the first term, I'm left with just 6, because that times that would be 30x squared y. If I factor it out of the middle, I have minus 5. That gives me my negative 25. I have x squared, because x squared times x squared gives me my x to the 4th. I have my y already, but I'm going to need a z for this guy right here. So that's going to be our middle term, negative 5x squared z. On the end, 5 times 2 is 10. X squared times x is x to the 3rd. Y times y is y squared. And I need my z to the 5th. So there is that problem in factored form, factoring out the GCF. All right, last but not least, G. Always look for a greatest common factor, and I think a 3 does factor out in this case, luckily for us. So we have 2x squared minus 7x minus 4. So always factor out a GCF first. Now try and factor the leftover stuff. So my first two terms have to be 2x and x. And now my outside terms have to multiply to get 4 and add or subtract to get 7. So if I had 4 and 1 and made this negative, so that's negative 8x, and positive, so positive 1x, negative 8x and positive 1x would give us negative 7x in the middle. So that is our fully factored form. All right, so that was kind of quick, but we had a bunch to do there. Are there any that you would like me to go over or re-explain?